um, we'll start with our sequence behavior. It's fine. Um, so our sequence behavior is, like I said, an and statement. So it needs to have both of these to be return success or running in order for the sequence itself to return a success. Um, and so we have, if we check for enemies, like I said, and it returns false, it'll immediately say this is false. We can go back to task patrol. Um, and so if we go over here and we say, um, what is it? If we have a failure, we want to stop, right? And so that's exactly what we see. We fail to find any enemies in our check for enemies function. We don't want to execute move to enemies because there is no enemies to move to. Whereas if we have success, we want to continue evaluating the child node. So if we find an enemy, we're going to keep going and actually move to the enemy. And then same with running, right? There is a little bit of a caveat though. We have any child is running, which is just a boolean, and basically what's going to happen here is this little question mark. Any child is running node state dot running is going to say if what is it? If any child is running and the node state is running right now, then it's just going to default to node state success, and then it'll return success, right? So basically, the sequence will say if it's running or it's succeeded, then we can consider the sequence itself to have succeeded. Is basically what this right here is saying. Because what you'll have is some of these nodes are running, some of these are in success state, and so it just wants to basically just makes running equal to success, right? And so we get a lot of good behavior from this. Like I said, we have our here's a YouTube link, by the way. I was considering swapping it out for the Never Gonna Give You Up for April Fools, but missed opportunity there. Anyway, so like, yeah, exactly. um, anyway, so like I said before, I'm gonna go back here real quick and just explain. Now you might be able to see where we have our selector up top here as the root, and we're saying if the sequence is true, then we're going to execute the sequence. If not, we're going to execute the task patrol. And so it's actually evaluating sequence first and then task patrol second, which is completely fine because it will check for enemies, and if there's no enemies, it'll jump back. It'll say this sequence has failed, and so we can go say, okay, let's go back up to selector, select the other one, let's see what's going to happen there. And of course, task patrol is our default behavior, and so we get our task patrol, and then vice versa, right? And let's see here. So we have, I can break down sort of, let's see, the actual node itself. We also have the actual tree structure. I'll see what I can say about this. Yeah, so this tree structure doesn't do much as far as it just is a sort of intermediary for an actual a tree. So we have this B tree inherits from mono behavior, right? But then we can see that we have our guard BT inherits from behavior tree. So not only do we get mono behavior, which just allows us to attach it to a game object, but we also have the B tree class, which actually makes a tree and stores the data related to the tree as far as like the root node and all the subsequent nodes. So you can see here, this is where we just were actually. Let me go over to node. And so nodes are separate from trees, and that a tree is comprised of nodes, right? And so here's our little enum. Again, the way I would look at this is just it's almost as if you had a Boolean, but your Boolean could have infinite states. So you could set another state. Let's say we wanted to make joke. I don't know. That would also be a state. And so then we could just use a switch statement on that instead. And so basically it's just used for clean code because you could just say 1, 2, 3 if you really wanted to, but that's kind of hard to understand necessarily. And so we use enums instead. We also have, of course, our node state, which is our, like I said, the enum we have up here. And so now from each node, we have our children, of course. So basically what that says is that when we have selector, its children are task patrol and sequence. when we have sequence, its children are check for enemies and move to enemies. And so it'll point to the different nodes we have. And this is just sort of the background. I don't want to get too in depth with it because realistically, you don't want to change any of this. You just want to maybe, at most, you're going to add another node state. Even then, I don't necessarily recommend doing that, only because you only really need to know if it's running, it's succeeded, or it's failed, especially for the selectors and sequences. If you need a fourth state, there's probably a way to implement it better inside your individual node class, and I'll show you some of the nodes that I've built here for this. So we have, we'll go to patrol first. So all this patrol does is it has a list of waypoints, the transform, I believe, of the actual enemy, and then we have our character info and our pathfinding. And so what we do is when we make a new node of task patrol, we actually pass all these values in. And then as well, when we evaluate the node, what we're just doing here is we're saying it's basically just a tiny state machine. It's saying we're gonna move to this point, wait for a minute, move to that point, wait for a second. We can increase the time dynamically because it's it's a Boolean, but we also have the actual wait time itself, which is a float. So here we go. Yeah. Okay, I see. Yeah. So we have our movement controller, what I've done here is, so whenever you make a static class, you can actually refer to it from anywhere. So normally what you have to do, right, is you've seen probably the serialized field, or you've made it public and you've had to go in here and maybe like hit this little plus icon and then add in some kind of script or something. What you can do is if you make your function static and then don't inherit it from mono behavior, that means you can access it from any script at any time. And so you can see I'm not actually referring to a movement controller. You can see I'm moving to the movement controller. You can also see that I don't actually have a movement controller script anywhere in my scene. And so what that does is it helps because it means I don't have to, I don't have to make it an actual object anywhere, which means if I load a different scene, this movement controller is always in it. And also I have all of course, movement controller's functions. I'll go along a little bit more of what movement controller does because it's a little bit different from the original approach. It's more disconnected, but that's the thing, is it's actually better for code to be disconnected because it means when you change things, they don't necessarily break as often. So be thinking about that as well when you're making things, is like, how can I maybe make this generic or separatable from the rest of the code, especially if you're using code twice. Let's say if you have an enemy and a player, these are both going to use the movement controller, and yet inside these players we're including the movement twice. Now you could say the same thing for health. Maybe you don't really need an enemy health bar and a player health bar. You can just serialize values on it and make a generic health bar. And so here we'll go into now the enemy in range one, and I just want to, it's really basic. It just says we're gonna check inside the circle, and then this is just the sort of like well, it's two things actually. For one, it says it gets the center of the circle, it gets the range of the circle, and this 64 right here, excuse me, is quite interesting actually. So layer masks. Layer masks are a way that we can look at a specific collision layer, and what I mean by that is if we click on this, go in the inspector, scroll up here, we have something called the layer. And so layers help us separate, checking for different objects with collision and things. So we can effectively choose what layers we want to see in a any kind of physics raycast function like here. And so since I just want to be checking the player character, what we can do is, you'll see it's not 6, it's 64. If we go up here, the character is actually layer 6. And so the reason it's 64 is because it works in binary. So layer 1 or layer 0 is 1, layer what is it? Layer 1 is actually 2. Layer 3 is 4. Layer 5 would be, what is it? That would be 8, yeah, and 16, 32, 64. And so now you can kind of see, I forget, I think one of these layers isn't accessible. That's why it's kind of weird like this. But basically, 64 means all we're going to be checking for is this 6th layer, the character layer. Oh, yeah, because it's 0 to 6, so it's 7. That's why I was getting confused. So, yeah, technically, by technicality, this is the 7th layer. It's going to show up because it's like it's counting by array, which means it's like 0, 1, 2, and so on, instead of 1, 2, 3. Okay, anyway. So the nice thing about that is because the reason they did that is because now you can say I want to check for layer default plus the character layer, and let's say also I think this one is the raycast layer. And so if I wanted to check for all these different layers, all I have to do is input this instead of just that, because it'll give you a very specific integer, which will what is it? It'll give you a specific integer, which means you can get the all those layers. So you could type in a random value too. Let's say we don't want to type in 1 plus 64 plus 4, and we wanted to just type in 69. That's the same as writing all that, essentially. And so that's sort of a fun way to think about it. If you're ever trying to just find specific things with collision, I kind of went on a little tangent there. Sorry to break things up. But hopefully that kind of teaches you something. This is just a debug. I'm going to actually remove this. There's nothing going on here. It was testing when I was building this. Okay, right. And then so we have each node. And so what you want to do if you're, what is it? When you're doing these nodes is just be mindful, because you can't just write this and expect the node to do it for you. You have to actually set the state and return it. And so we'll see when we have collider found units, we'll give the data to a dictionary. Dictionaries are a very hard concept for me, but I can definitely explain it to you guys, and I will do so in a minute here. But basically what's going on is we return success if we have colliders, which of course this is the enemy in range check. So we found an enemy in range. If we found a target and the target doesn't exist already, we can set the state to failure. Basically, we said we don't have a target and we didn't find one. Because we found a target, we don't need to do this check. So we have a target, right? And so we can just say we return success if we have a target already. Is basically what's going on there. So that's the enemy in range function. Let me jump over to the dictionary. So we have parent.parent. And so when we do, the reason we have parent.parent is because it inherits from the node class, right? And so we go over to node, we have a parent node. And so just as these nodes have children, they also have parents, of course, which means if we go over here, the parent of this node would obviously be the sequence. And so we're going parent, which is the sequence, and then we do parent, which is the selector. And the reason we want to do that is because we want our data to all be stored on this root node. And so that way, when we point to this root node, we say, let me gather the data from this root node. It's sort of just a central place where we can take any of our behaviors and look up different things from them. So let me go ahead and find parent.parent. That was an enemy in range. And then we had set data. And so this is where we're talking about the dictionary. Let me find, yeah. So we have dictionary, which it takes a string and an object. So we can say, basically what we're making here is like a list of variables without actually making a list of variables. So I could say transform target equals, I don't know, I'll just say transform, right? And I could say enemy 2D enemy equals enemy or something like that. Basically, I could be writing all these values out, but instead what we're doing is we're basically just making an invisible field, or was it not field, but an invisible list of values. And so all we have to do now is we can say, when I want to get the target, I could just say, okay, so string, I want the name target, and I'm going to get out the object. So I can get from, let's see. So when we set data, we can also do get data, which returns the actual values, right? And so that's what this whole deal is with the set data and get data. It's basically an invisible, what is it? Variable list is all it is. A visible variable list. I'm going to leave that there, actually. And then, of course, I'll move on to movement controller, because that'll explain some things before we go into the actual, this last one here with the go-to. If I can... It's going to wait. There we go. Okay. Scripts and movement controller. Gotcha. So what I realized is that because we won't be getting mouse information from the enemy character, I'm going to take the movement controller and make the mouse controller a separate thing. But I'm not going to, I'm going to make the mouse controller call movement controller. And so what we get from that basically is we can say we have our the old function here, which is Michael had already written, which is our nice move along function. We also have now our character position online in here, and then I believe the get tile from position is new. Basically what this does is it gets the tile from a world position. And so the nice part about that is that we have, the really nice thing about Unity rather, is that you can, it has the functions built in. So all you have to do is I can say get tile from position, hand it a position, and then I can get the self position from a tile map. And since this map manager is also a static class, I can just say, or no, sorry, not a static class, but it's a singleton. I don't really want to get into what a singleton is right now because it's a little bit interesting, but it's also a variant of a static class. It's not necessarily static, but it goes into other scenes. And so we have the instance of that static class calling the tile map, and then we can call from the tile map, we can say, give me the cell position. And of course, since we have this nice inside map manager, we already have a map of all the cells we made, then we can just grab it, the cell position. And so that will point to wherever we're trying to move to, basically. Because if we didn't, we'd have to like serialize the actual sort of cells themselves, and that's really difficult to do because, for one, these grids are all being drawn at runtime, which means we can't serialize them. We have to find them later. And so that's exactly what we kind of do, where we have two objects. These are actually spheres, and I can move them actually. Let's show that, I guess, right? Let's move them over here. And they'll grab these cells from right below them, and so it'll say move to that, and so on. I'll play it real quick. Watch it break right now. There you go. So yeah, it said, let me find that cell, let me find that cell. You can actually add more waypoints. I just had 2 because you don't really need to see 3 to know the concept, get the concept. But I'll show that real quick because you can just, nice little thing here is, am I in the right? I'm not in the right one. That's the, there you go, enemy is, there you go. So with the guard BT, we can add these waypoints in, and you can make a third or fourth or fifth or infinite, and nth amount, as a math professor would say, or something clever like that. Anyway, so of course this get best tile is what we're using for our go-to behavior, which we're finding what is the closest tile that isn't occupied by an object or another character that we can go to. And so it finds that using this function, and this function calls another function. We have get cardinal neighbors, and cardinal in this sentence just refers to cardinal directions. So we're saying north, east, west, south, that kind of deal. And the only specification for that is because we aren't getting the corner neighbors necessarily. We're not getting southwest, northwest. You get the deal. We're just getting the up, down, left, right. And so we'll actually, when we get cardinal neighbors, we will for one, we'll actually see if it exists in the first place, and then once we do find it, we'll add it. And so that makes a nice generic function for us. If we find all these, sorry, looking at the thing. Okay, we're good. If we find all these, then we're gonna check for each of them, and we're gonna say if these are. Let's see. Hold on. Let me see. Maybe I'm doing the check for. Oh yeah, here. So I'm actually doing the check for if location is blocked in neighbors. Sorry. And so we have the. Now we're just checking for the closest distance. Gonna say, let me find the closest one. And this is just a simple distance search. I'm sure you've all done something similar to this in CS111, if you've taken that. Anyway, and then that's pretty much how it breaks down. So we find the 4 neighbors, we check if they're blocked, and if they actually exist in our neighbors function, then we find the best one, the closest one to our current position from the enemy. And so, like I said, this is the sort of behavior we get as we keep going back and forth until we get close enough, in which case it's more like a zombie than anything. Oh, there you go. Yeah. Clearly some issues with updating. I have a list of, or a bucket list of things that are, that could be done better with this representation. For one, obviously you just saw one, which is it'll find, we were in this tile when it called the function, and then we ended up in this tile because we were still moving, but it sensed us right here, and so it moved over here, realized, oh, wait, we've already moved, and then went over here. So 2 things. One, the distance isn't Manhattan distance, so it just finds the literal closest position it can get to our unit, not actually the closest cell it can occupy. And so you can kind of even see it here. It's actually occupying like this weird, like non-cell specific position. And so that's a fix that needs to be done. And I can help walk you through that later if you want, Michael. But basically, hopefully now you've understood. I would appreciate it and hope you guys have some questions, because I understand, again, that was a lot, especially if you've are not familiar with all these different concepts, most of which are specific to even Unity. So if you want me to like break down, I'll give you some options here. I can break down enums. I can break down the layers again. I can break down the tile map, how I'm using that to find the neighbors again, or even just the behavior tree again, and how you could set up your own structure if you're not really sure.
Can you go over the static variables, like how you can call them in different functions?
So there, do you mean the static scripts or the static variables I'm calling from the dictionary?
From the dictionary?
The dictionary one. Okay. Let me open that up real quick. So basically what we have here is for every node we are making a dictionary. This dictionary by default is empty, but basically we can treat it like a list. And so, or an array or a list. And so the nice thing is because C# is not painful, we can just say we're gonna make a dictionary of objects, and we're gonna have the key be a string. And so what this kind of creates for us is that we can assign a name, a type. Let's just say transform, right? A name, a type. I'll actually just say type. Name, type, and we can even set a value for it. And so we can keep doing this for any type, any name, any value, so long as we don't use the same name twice. Because obviously it's going, if we are setting a value for something, then it's going to override it. The way a dictionary works is, let me see if I can think about this, or so give you a better demonstration. Let me open up.
I think I could explain it.
You got a good? You want to try it?
Yeah, a dictionary basically, it's like a dictionary, right? So like a dictionary, you know, it has a bunch of words in it, and each word is a definition. And but instead of words, you can use literally anything. The one in yours is like strings, yeah.
Exactly.
And then for each of those strings, there's a definition. and there's only one definition per string,
Yeah.
basically.
So like I was trying to explain is basically it's exactly like making like here we have a public node parent. That's exactly the same effectively as doing what we're doing
Oh, so
before.
is it like making a reserve or where kind of?
Yeah, so basically like I said it's an invisible list of these things up here, which is just any
Okay.
variable. It's an invisible list of variables that we can set at any time from any one of these nodes. Um, we just want to do it from the parent node because then we can refer to that data from any other node because we know where the parent is relative to the actual node itself. I'll show that because that's a very like wordy sentence. Basically, what I'm saying is we want to store all of our data up here because it's not confusing to think, oh, this guy is the data for if we want to access data for this guy, we can get it from this guy by just calling the parent once. And then so if we want to go down again, we have another node. If we want the data from the guy above us, instead of pointing to the guy above us, let's just point to the guy above him, and so that we have all of our data kind of in this one central area. And the reason we do that, of course, is because if we have multiple nodes, even maybe of the same type, we always want to get our data from this data center or root, or sorry, the root of the behavior tree, and because it makes it easier to know relative to the node where to get data from. So let's say we have a specific node, like let's make this box, make it different, right? And we want to grab data from this side of the tree even. We could say, instead of having to like, okay, parent, 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 child, we could just say parent, 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 and then we know our data is going to be in this data over here because we've passed that data from our child to our main thing here. Hope that's sort of clicking now. It's just a nice way of thinking about things rather than trying to find like, okay, this guy's over here. I need to go find him from going up this and down here, and maybe this guy branches again. I need to find child of this and make sure it's the right child, make sure it's the right child. Instead, I could just pass it all up into main friend here and say, okay, grab that data from him. Is there anything specific you wanted to know about it, like how to set data or get the data?
Then can you like show example of it?
Sure, not necessarily like directly, but I can tell you exactly what's happening here. So we have this function, which is called set data. We have a string called the key and an object called the value. So a string, obviously you know what a string is. It's just a word. So we'll just say this is the word variable, and that's our key. The string here is synonymous with the word is synonymous with the key. They're both the same thing. And so we have then our object. Object can be anything, and I mean anything. So we could have it point to a unit. Sorry, let me actually spell correctly. We could have it point to a unit, or a position, or a I don't know, the character. And so that's just something that's nice with C# is we can point to any object if we specify the type object. And so now when we set this, we're going to save it to our dictionary, and we're going to say our value is our object. So we have, let's say we put unit into our first thing here. Say unit is here. Then how are we going to grab that? Well, we have our key, which is word. And so now we've made a variable. So now all we have to do is say, whenever I want to get this, I can just type in or specify I want to get the word variable. And I can say get word. And so the parent, obviously we have to point somehow to the parent node, or sorry, the root node, which is, I'll show you over here, which is our selector. And so if you're trying to get data from this node, you're going to want to say parent twice. Or maybe this node, you want to say parent 3 times because you want to traverse up back to the root node, so you can get data from the root node. So that's the whole deal with the parent situation. And so that's variable 1. We could also go do the same for position or the character. And you'll notice again, like I said, these are all different types. They're not all vector 3s. They're not all vector 2s. They're not all transforms or colliders or whatever, right? And so you can save the value and then get it by just typing in the name of the variable that points to the value. That's a lot of words there. I'm going to rephrase that for you. We can get the value by specifying its name. So we just say, I want to get the word variable, and it'll immediately grab the unit variable for us, or sorry, the unit value for us. And sort of, hopefully it's clicking. I understand again. Even for me, I remember learning this way back when, and it was very like, I don't know how to use dictionary. What am I doing? And it is very confusing. And that's the thing, is like, if you don't understand it, don't feel pressured to use it. I would say just if you need to get data from a node, so let's say we want data not from check enemies, but we want data from move to enemies, and we want to pass that to task patrol. We're going to have to just say parent.parent.parent to go 3 up, and then we're going to call this function they call over here, which is our excuse me, my nose is bothering me. Let's see if we can find it. Here. Yes, we're going to get data or set data. And so we're setting the data because we want to we want to have the target known so that we can check whether or not we already have a target. And then we can check if target is not null, then it's just going to return success. And so that makes it easy to pass the data between nodes. Otherwise, we would have to deal with, let's say we had a variable in here somewhere. Public transform test. If we wanted to access this test variable here, we'd have to find it relative to where we wanted it from. So if we wanted the enemy in range, let's say this is the enemy in range node, and we wanted to grab the data from here, from the other side of this tree, we would then have to say, okay, let me find my node here. And so we'd have to go all kinds of crazy places, and it basically just makes it a lot harder for us to think about where we want to get a node from. So I can go ahead and delete that. Again, I'm probably overloading you so much right now. I'm sorry. I'm trying my best to explain it simply, but there's not really a good way to go about that nowadays.
I'll figure it out eventually.
Mm-hmm. Yeah, again, I'm here if you have questions, and I can maybe explain it to you in a way that is more situational. I understand, again, it's like a lot of coding is just, like you were saying yourself, is just, I'll figure it eventually, because you might end up using it. And so you kind of have to just get in the groove of using it and understand it really. There is a video here that it goes over how to actually build it in code, and they explain some good things. If you're interested in that, that's in behavior, the B-tree file. It's not a Rickroll, I promise. But hopefully you might be able to get some more information from that, or out of that even. There was another question I heard. If you want to go ahead and ask.
1 second, I'll be right back.
No worries. Was there another question out there who wanted to?
Everything makes sense to me. So.
All right. Well, yeah, like I said, I'm here if you need me to explain it in a way that's more situational. It's very hard to just be letting me do the explaining and not have some sort of example that you're actively working through, right?
Yeah.
So. Okay, I'm back.
All right. Cool. So that was pretty much all I wanted to go over for that. Let's see. Let me make sure. Yeah, because I went over the changes. I did make some changes to character info. It's not a big deal though. I'll explain. I can just show that to Michael. And right, I didn't implement the turn controller. I started it, didn't do it. So don't rely on anything in here. And then let's just go scripts. That was scripts. Yeah, and that was to go to. We went through all the trees and the nodes. Okay. So yeah. Again, sorry for maybe explaining a lot of things in a convoluted manner. Not it's a difficulty, especially with these things, because for so many of us, this concepts are very new, especially with those enums. What is it? The dictionaries, and there's one other thing. But I hope, again, if you have trouble understanding it, maybe find an example where you're confused, and then just call me, man. I'll be there. Trust me, I'll be there. All right.
So for the tree, how you have it, like the success, the enum thing, that's like in game dev they call it a finite state machine.
Yeah.
Where you,
Mm-hmm.
so is it kind of like that?
It's very similar. Basically, what we're doing here is we're making a bool with different states. You know how it's a boolean is really 0 or 1. Instead, what we're doing is we're adding multiple states. So now instead of saying 0, 1, or 2, I can say running, success, or failure. And really, what that does is just makes it a lot easier to track what's actually going on. Because if we just said, oh, state of this node is 0, that doesn't really tell us anything. And so we don't necessarily want to use that. It's a really nice way to indicate what's actually happening. Because you could just say, oh, 0, 1, or 2, but we don't necessarily want to do that. It's a lot nicer if we write running, success, or failure. And so that's exactly what we've done. Where we have let me find the B tree, where we have the different sequences and successes and failures. As I probably explained a little bit, maybe too in depth. All right. Was there anything specific about that, or did I kind of
It's
cover it?
like the states, right? Like
Mm-hmm.
if then the player is close, it'll go to the player, something like that.
Yeah, right. This thing is like we have they're not
And then
necessarily it doesn't necessarily give us any information. It just tells us the state of the node, and the reason we do that is, of course, because we want to know sequences depend on both the child nodes being successes for the sequence node to be a success, and the selector node relies on failures and a running or a success to be a success. Or I flipped that last part. Sequences, success or running. Selector is just success. Okay. And so, like I said, I tried to explain it best in comments, so you don't even necessarily need me to go over this later. But hopefully you can get an understanding of what these jump statements are as well, and also what the logic of this it really is. All right. Any more?
I think that's good for me.
All right. Thank you. Thank you guys for coming. If you have any more questions about your own projects, I'm still here for a little bit. If not, then I'll catch you later. And yeah.
During one of the meetings, did like one of the ones I missed, have we like gone over scenes yet?
No, I've been saving that. I can do that next
Alright.
meeting if you'd like. We can go over loading and saving things.
Because that's something that's probably important for mine.
I got you.
Because I don't really understand Unity scenes really that well.
No worries.
And for my little demo, I probably want to have like, you know, like an equip, like choose your fighters, whatever screen, and
Okay.
like a battle screen.
I got you.
scene.
Yeah, that's what was it? Kenneth is also having, is he has an overworld and a battle screen. So I'll get you guys. I'll cover you guys next week.
Cool.
Thanks for letting me know, because it's always good to get that feedback. Is what sort of do you need to learn, in order to understand things. So, all right. Well, like I said,
All right.
if that's all you got to say, then jet out. If not, if you want to stick around, it's all good. I guess, Michael, I should ask, you got my message about helping out with the...
Oh yeah.
Okay, cool.
Yeah. I
April Fool's, nice. Okay. It basically just like, because I'm working on trying to set up the event stuff,
Yeah.
I could use some help.
Okay.
Yeah.
Yeah. I'll
No worries. I know you're busy with, you're saying you got midterms and stuff, so, I mean,
Yeah.
it's not a big deal. Just, get it done
Yeah.
eventually.
Yeah. Okay.
Oh, did
Alright.
you do the 231 midterm yet?
Oh, for our class? No, we're doing that next week as well.
All right. I think ours is tomorrow.
Yeah, gotcha.
Fun.
Oh, yeah, tomorrow's Sunday. So I think you just mean Monday. Nobody meant
Oh, Monday. I mean, yeah.
I know, it feels like the
day
week is
off has
going
me,
by.
The day off has me.
I know, it feels like it's going by so fast. Yeah.
Yeah.
All right. Like I said, I'll let you guys go. I'm going to stick around until you guys are gone, but
See ya.
see ya.
Dude.
Bye-bye.
Oh.
All right.